about responding to extended events in near real time. And thank you for joining us for this conference. This is what will happen today. This is the schedule for the morning. And this is the first session. We'll have a break in the middle of the morning. Then second session, lunch, and we will have a lunch session by Pyramid Analytics. And then 3 sessions in the afternoon. My name is Gianluca Sartori. I'm an independent SQL Server consultant, SQL Server MVP, and I've been working with SQL Server since version 7, so a long time ago. And currently I'm working as a DBA at a famous Formula One company in Italy, the one with red cars and prancing horses. And if you want to follow my blog, you can find it at spaghettidba.com, and my Twitter handle is @spaghettidba. Okay, so what we will see in the next 90 minutes, we will have a quick overview of monitoring, or why we do some things with monitoring, and how we can extend that with extended events. We will go through the core concepts of extended events, even if this is an advanced session, because we will try to shed a new light on those core concepts. We will try to look at those concepts from a different angle. And then we will see the streaming API, how it works, and we will see some possible applications. And then we will also explore Extended T-SQL Collector, which is a project of mine. And basically it combines extended events and the data collector to collect data from extended events and save it to monitoring database. Okay, so let's go. Monitoring. Why we do monitoring? We all are monitoring our SQL Server instances, and we do that basically to answer questions. So the questions could be for troubleshooting. So the question would be along the lines of, what happened tonight at 3:40? So we have an ETL process that's running, which is overrunning. Usually it takes 1 hour to run, and then all of a sudden it takes 3 hours, and the developer or who's in charge of the ETL process comes at your desk and asks why the process took more than usual, and you have to have an answer for that. And the only way to know is monitoring. Other reasons why you want to be monitoring: you want to tune performance. So example of questions you want to answer: which queries consume most resources? If you're not monitoring that, you cannot answer the question. Or maybe you want to do capacity planning, so you want to know how fast your databases are growing. And the only way to do that is, again, monitoring. Or maybe you want to take a baseline of your performance, and if you want to know if your system is behaving normally, the only way to know that is to capture something that is normal and compare to that. And that thing is a baseline, so you have to capture it in order to know if things are behaving normally. Or maybe you want to do some alerting. So what will happen is something goes wrong, and you want to be notified when things are wrong. So how you do your monitoring? The easiest way to do that is to buy a commercial product. So there's lots of high quality products on the market to do exactly that. You can go to SQL Sentry, Redgate, SolarWinds, Dell, or whoever you prefer, and they have solutions for monitoring. They cost usually a lot of money. So just to give you an idea, it's 2,000 euros for a single instance. I don't know how much is that in GBP. You can do the math. But again, it's big money for a big value. You could also go on the internet for open source or free tools, and there are some, but usually they are incomplete, or they were built by somebody who was trying to solve a particular problem. He solved it, published the code, and never looked back. So if you want to solve a different problem, you will have to fiddle with the code. So it's not something you download, install, and that's it. And you could also decide to build your own solution. And, well, if you compare how much that costs to what a commercial product costs, you will easily notice that the cost of doing that all of yourself will be much more than buying something from the market. Your time has a cost. So you will probably have a better chance with a commercial product. Different mixed solution could be using some of the SQL Server built-in tools to monitor not the whole system, but just what you want to monitor, so the exact problem you want to solve. So you will have some tools in your hands, such as SQL Trace or event notification alerts, extended events, and the data collector. You can combine these solutions to build your own monitoring solutions. And in this, we will see how we can use these tools built in SQL Server to achieve that. So before SQL Server 2012 arrived, we could have basically two possibilities for monitoring. We could be pulling some information from performance counters or DMOs. So basically, when you install SQL Server, you have your performance counters installed in the system as well. You can be polling those counters regularly and see the numbers you get. You record those numbers and you save them to a file, a database table, everything that works for you. And so you have some performance counters for the operating system and some performance counters that are specific for SQL Server, and you can be polling those regularly. Other things you could be polling are the DMOs, so dynamic management views and dynamic management functions. So they expose lots of information, and you could poll that information regularly and save them to a table. If you want to capture everything that happens on your instance, you have to rely on SQL Trace, and that's what we had in our hands until SQL Server 2012 arrived. So SQL Trace allows capturing all the events that are defined in a trace, and all these events go to a file, and you capture all the events to that file. With extended events, we have a new possibility. It is meant as a replacement for SQL Trace, even if it was introduced in SQL Server 2008. In 2008, we didn't have a complete replacement for SQL Trace because we didn't have all the events available in SQL Trace. We didn't have all the columns we had in SQL Trace exposed in the events. And so really, it wasn't a real replacement until SQL Server 2012. It is a lightweight event capture infrastructure, so it has a lower performance impact on the instance compared to SQL Trace. And also, it is hooked deep inside SQL OS, and it allows capturing some events that are not available in SQL Trace. So let's go through the core concept of extended events and see what we have. So the core concept number one is the event itself. The event is something that is fired by SQL OS when a point in code is reached. What does it mean? That inside SQL Server's code, there will be some places where the developers put a call for raise an event. And that event tells us that that particular point in the code has been reached. And all the points that are important for us will have that call to raise an event. And also, when the event is fired, it will contain a payload, some information about the state of the system when the event itself was fired. And this payload is the fields. So all these fields will contain values that describe the state of the system. We will also have some additional fields that are called actions. They are not really available in the event, but we have to do some additional calls to external functions to gather those information that we want to put in the event through actions. Then we have the session. The session is what defines what we want to capture. So when we set up a session, basically we decide which events, which fields, and which actions we want to capture. And that's the session. And then we have the target. The target is what actually consumes the events that we capture with the session. And we have several types of targets for different applications. So it depends on what we want to do with the session, which kind of target we will choose. We can attach multiple targets to the same session. So we could be writing to a file, to a ring buffer, to whatever we decide is appropriate. And also, we could define a session without attaching a target at all. So we could have a session with no targets attached. Okay, so types of targets. We have different types of targets. The most popular ones are the first two, so the ring buffer target and the event file target. Ring buffer, basically, as the name suggests, is a circular structure in memory, and new events are put in the ring buffer, and when the buffer is full, older events are evicted from the buffer and new ones are put inside the buffer. So it's useful when you have to record for a short time some events and you want to keep them in memory readily available. The event file is very similar to what we have with SQL Trace. So the events are captured, are saved to a file, and then you can inspect the file later to find whatever you're interested in for your analysis. And then we have some special targets that we will use in special situations. So, example, we have the event pairing. This is used for events that usually come in pairs. So, example, lock acquired, lock released. And when you use this event pairing target, you can identify those events that have pairs that don't match. Then we have the event tracing for Windows. This is used to combine information that comes from SQL Server with information that comes from Windows. And you can combine the two with this ETW target. Then we have some two targets that are used to count events. So we have the event counter, which basically counts all the events in the that come to the target, and the histogram target that is used to group the count that we do on the events. So we can use one of the fields or the action as a grouping field for the count. And this is the URL when you will find the description of all the targets. Okay, great. So we're all covered. We have targets for whatever we need. Actually, something is missing, and there's no target for alerting. And there was a request for adding it through Service Broker, and here is where you will find it on Connect, and it was closed as one fix. Surprising, isn't it? And why Service Broker? Because Service Broker was what was used by oh my God, the counterpart with SQL Trace, which is event notifications. So this is the reason why Service Broker was asked. So what can we do since it was closed as one fix? Possible solutions. We can post-process the target. So we can save to a file and later go to the file, see if the event we're looking for is there, and then do some action in response to that. But it's not fast enough. The file will be available after some time, so it's not good enough for alerting. We could poll the target for changes, but that's really ugly, so I don't like that solution. We could use something else, so we don't have to use extended events, but some events are available only in extended events, so we'll try to find a solution for that. If you decide to use something else, you have alerts, so the SQL agent alerts, they still work, or you could use event notifications. You will have most of the events that are in extended events available for SQL Trace and event notifications as well. Well, maybe there's a hidden target type that will help us in this regard. So how many of you used the watch live data window in extended events? Most of you. And have you ever wondered, how does the thing work? It displays events as soon as they happen, so it must be hooked to somewhere. And what's that somewhere? If you take a look at this DMV, sysdmxc session targets, this describes all the targets hooked to active sessions. When you have the Watch Live Data window open, you will see that something turns up. And the target name is Event Stream. And in target data, you have live stream, target, truncate, blah, 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 blah. So that means that we have a target type that is not documented in Books Online, and it will be available through something different from what we have in T-SQL, which is the Extended Events Streaming API. And I will show you how it works with a quick demo. So we will try to display the events as soon as they happen, as we do with the Watch Live Data window. Okay, so in order to do that, we will open a connection to SQL Server 2014, and then we have so we have to do some setup first. We will create an extended event session. Let's close this. Okay. And this is what it will capture. So it will capture RPC completed events, and then SQL batch completed events. Okay. And this is all the actions that we want to capture, so lots of actions. And we're filtering both events for a specific user, this replay user. Okay, so what else are we doing? We will need a database, and we will need some users. Okay, so basically we will create a login, this replay user login, and we will add that user to the replay.db database. Okay, so good. And then we will need a workload. And this is the dumbest workload you will ever see, but we just need to capture events, so it doesn't have to be meaningful. It will basically insert into the test numbers table one row. So let's have a look at the test numbers table. Basically, it's a table with a single column with identity, so it will insert a new number every time. Great, so let's start the workload. It will start inserting rows inside the table. Let's have a look if it's working. Okay. Okay, it's working. So, as you can see, the numbers are going up. So here we have these numbers that are getting inserted into the table. Okay, so if we have a look at extended events, here we have a session. This is the one that we just created, and we can have a look at that with the watch live data window. Okay, as you can see, we have the events that are showing here in the watch live data window. Let's try to do the same thing using the streaming API. So here we have how many DBAs do we have here? How many developers? Okay, so warning, I will open Visual Studio. Don't run, don't panic. Nobody is gonna get hurt. Okay, so what do we have here? We have a window with two panels, and this is what it will display. Okay. Cool, so let's start this project and let's see what it does. Okay, so it's doing exactly the same things that the watch live data window is doing. So if we click on one of these events that we are capturing, we will see all the fields and the values. How is this working? Let's have a look at the code. So, first thing that it's doing, it's using a connection string to connect to the instance. So, no surprises here. It's a normal connection string. And then, what it does is it instantiates this object, and the name is queryable event data. And this, in the constructor, takes a connection string, the name of the session you have to connect to, and then two constants, event stream, this one, that tells that we are attaching to an event stream instead of an event file. This same API can be used to open event files, and do not cache. And then, very, very simple, for each event in the stream, do something. So basically we can enumerate the events that we have in the stream, and we can do something in response to each of the events that we capture. And then what are we doing? In this case, we call this add row, passing this object, published event. Let's have a look at what add row does. Add row simply adds a row to the top panel, this one. And then this is what we have in the second cell. So one of the properties is a timestamp of the event. And then when we click one of the rows here, we are filling this panel with information. So let's have a look at what it does. Okay, so this is the event that we get, and then we can enumerate all we can enumerate all the fields in the event and all the actions in the event, and each one has a name and a value, and this is what we display in the second grid. So really it's that simple, really, really simple what we're doing here. So let's stop it, and let's stop this one. Everything clear so far? Great. So what we have seen, we had some events that showed up in a queue, and we could process those events. No XML shredding. So, I mean, no XML shredding. Fields and actions are available as properties of the event. So that means that we can inspect all the fields and the actions that we have in the event, and we can do things with those information. And possible applications of the streaming API. Well, we could watch events as they occur, but I suppose that you have better things to do than watching events that show up in grids in a screen. So more meaningful things you could do. You could perform some actions in response to an event. What kind of actions? You could send an email or start a job or things like that. Have an alert when specific events are raised. Obviously, it doesn't make sense for all the events. So with extended events, we can capture events really deep inside the SQL OS. So it doesn't make sense to fire an alert for a lock-acquired event. You will want to capture events such as deadlock or a long-lasting blocking, things like that. You could save events to a target database. The events that are meaningful for you, you could take those from the stream and save them to a target table. So here what I will show you is a proof of concept. It's replaying a workload using the streaming API. So let's close this. No. What did I click? I don't know. Okay. Close, 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 close. Close solution. So why replaying a workload? We have plenty of possibilities for replaying a workload. We have a profiler, we have RML utilities, we have the distributed replay. All these technologies rely on the fact that you first capture the workload, save it to a file, usually a huge file, and then process the file to perform the replay. Using the streaming API, what you could do is replay the workload as soon as the events are captured. So you could have, as we have here, a first instance that is SQL Server 2014 and a second instance which is 2016, and we could capture the events that happen on this instance and replay them to a second instance. That makes sense, for instance, when you have an upgrade scenario and you cannot capture the whole workload from the production machine because it would be too large to save to somewhere. So you could replay the events captured on the production server on the test server to see if things would work. And this is what we will try to do here. Okay, so let's close this one again. This is what we have here. And what we need again is the workload. We will start it again. Oh no, wait, let's reset everything. Okay, and then let's have a look at the code first. So in this case, again, we will need connection strings. So this is for the source server, and this is for the target server. And then what we do here is we do some initial preparation, and then we process events. Process events does exactly this, what we did before when we were displaying events. So we instantiate this object, attaching to the source server, and then we process the events as soon as we capture them. Replay single event, what will it do? It will capture the events and then extract some information from the events. In this case, we will capture the database name, so this is it. And then we have to capture the command text. In case of RPC completed events, it's a statement field. In case of SQL batch completed, it's the batch text field. And then what we will do, command text, very easy, we will attach with a connection to the target machine and execute the command. So really, really simple what we will do here. Let's see if it works. Okay, so we just have to start this. And then we can query the tables. This is a source. Oh, no, don't do that. Oh, well, I think it works anyway. The source and the target. And as you can see, at the moment we have no numbers in both tables. So let's start the workload. And we should be seeing numbers flowing from the first to the second table, and this is what is happening. So this is a bit behind, obviously, because the events first happen on the source and then happen on the target. So it's a bit behind. You had 24 here and 18 here, but the numbers are flowing from source to the target. Okay, everything clear so far? Great. Let's stop this fantastic workload. And as you can see, when we stopped the workload and the replay is still working, is still running, it didn't catch up in the end. We will get back to that later, but it's one of the things to be aware of. It will never catch up. We will get to that later on in the discussion. Oh, well, so let's close this and okay. To be a complete replay solution, it misses a couple of things. In a real replay solution, you would have to group the events by the source session. You would have to take transactions into account and use different threads to replay each session. But as a proof of concept, you can see that it could work. So it's nice, but it's not available in the T-SQL realm. So we had to open Visual Studio. Do DBAs have to learn C#? It would be a good thing anyway, but no, they don't, because the streaming API is also available in PowerShell. So what we could do, we could create SQL agent jobs with a PowerShell step, or we could run a process in the background with a PowerShell script. And I will show you exactly the same thing that we have seen in Visual Studio. We will do the same replay, but this time using PowerShell. So let's have a look. And okay, let's reset everything again. And okay, so this is the PowerShell script that does exactly the same replay thing. Again, we have two connection strings, source and target, the session name, and then we have to instantiate the queryable XEvent data object. To do that in PowerShell, it's a bit more verbose, but you can do that with a new object, and this is what you will do. New object, type name, and you have to provide the whole name of the object, and then the arguments, the ones that we passed in Visual Studio. So again, the connection string, the session name, and then the two constants. So let's go here, event stream, this one, and do not cache. And then again you have the events, and you can enumerate the events, but this time we're doing that with pipe for each. And inside the loop we can do again extract the database name. The database name, the command text, which depends on the type of the event we're capturing. And then, again, we can instantiate a connection to the target database and execute the same command that we captured from the source. So let's try to do this again. Let's start the workload again. Okay, and then we have to replay. So let's start PowerShell, and what we have here is replay. So what it's doing, it's attaching to the session and replaying the events captured in the session. Let's see if it's working. So we have 40 and 8, and it's working. 47, 15. So the numbers are going up again. So let's stop this. Let's stop the workload. Okay, so again, really easy, even in PowerShell, really easy to use. Again, this is the core concept, the core object that you will use. Okay, so other things you could be doing with the streaming API. We have seen that the histogram target is an interesting target to use when you want to group on some of the fields that you have available in your session, and you want to count the events that you have in the session. But the histogram target can count events grouping on one attribute. If you want to group on more than one attribute, so 2 columns, 2 different fields of the session, what can you do? You can do that with a custom script that uses a streaming API. Also, if you want to do a different aggregation, different from the count, so you want to do a max or a min or whatever, you will have to do that with a streaming API. So let's try to do an auditing exercise with a streaming API. So we can audit table usage by using the streaming API. Why auditing table usage? So let's put this in context. Imagine that you have a new database that is handed to you, and you want to know which objects are used, which ones are not, and in order to do that, you would have to audit the usage of the objects. But using an audit records all the single events of the table usage. So every time somebody selects or data from the table, you will have an entry in your audit, and you will have thousands of those, and every time somebody writes to a table, you will have a different entry in your audit. So it's too big to just extract as simple information as somebody's using the table. So what you want to do is write to a table last time somebody used that table in read or write mode. You just want a date, last time somebody accessed the table, and a count, maybe, how many times somebody had a write or a read on that object. Okay, so let's try to do that using the streaming API. We can extend the possibilities offered by the histogram target. Okay, so we'll have a session here, and this is a session that we will use. And so in SQL Server we have the audit that is based on extended events, as you probably know. But the events that are captured by audit are not available in extended events directly, so we cannot use the audit package in this case. What we can use directly is something similar. So we will use the lock acquired events, and we will count shared locks as reads and exclusive locks as writes. Right? Okay. So we will use some filters here. We will capture resource type object. We will just capture user databases, so exclude resource DB and capture user databases and user objects, and the mode of the lock will be schema stability, intent shared, intent exclusive, shared, and exclusive. And this is the kind of locks we want to capture. Okay. And then we will need some tables. The tables will contain the data of the audit we are setting up. So again, we'll have here a database name, schema name, and object name, and this is the primary key of the table. It also includes the client application name. And then we just want to know last read and last write. We just want to have these two datetime fields in the table. And we also have a last snapshot table that we will use as a staging table, because we will capture the events, then upload them and merge them to the target table. So let's have a look here at what we have. We will set up everything. It just created the session and the tables. And then we will run a real workload this time. We have this database. It's called DS3. It's a benchmarking, it's an example workload database that's made available by Dell. And we know nothing about this database. We have some tables here, but we don't know which ones are used. We will run this workload. It's a synthetic workload, again, but we will see which tables are used. So let's start this workload. This will start some threads that will connect to the database and do things. We don't know. Oh, interesting. Okay. Let's try again. Wait. Oh, fantastic. Consistency problems. It's not time to do a check DB, right? Okay, let's do something different. Let's do something different, but will try to attach to a different workload. So let's have a look. We'll just need to change some of the filters. Let's have a look at the filters we have in the session. We'll just have to... Oh no, it's working. So it has no filters for a particular application, so it will capture everything. We could use a stupid workload that inserts numbers. So let's start this one. It's working, and let's have a look at what the script does in this case. So let's open this. Okay, so again, we have the two types that we have to add. The connection string for the source of the events, and then this will create a hash table of all the object IDs. We will use that to look up the names of the objects. And then we just have to, here it is, hook to the session. So again, a queryable X event data, and we will attach to the session name that we set up, and again we will loop through all the events, and we will capture database ID, client application name, object ID, and the mode. And then we have a cache. This cache is the cache of the object IDs that we captured before. And then we will find the row using an in-memory structure. So in this case, it will be what's the name of the thing? So here it is, the queue. This is a queue that we are using. Queue, here it is a data table. So here it is. We create a data table, and this will have some columns. Database ID, object ID, client application name. And this is where we will write the information that we capture from the session. And we will dump the data table to the database at regular intervals. And we will keep the data table in memory, and we will look up the object IDs in that data table to update the last read and last write columns in case multiple events show up in the session, right? So, for all the events, we will create a row. So if row not found, we add a row to the data table with this information. Otherwise, this is a row that we have found. And if the mode is exclusive or intent exclusive, we update the last write column. Otherwise, last read. And we dump to the database every 30 seconds. So what we do here is, if 30 seconds have passed, we use a BCP object, so a SQL bulk copy object, and we dump to the last snapshot table. And we merge the data using this merge statement, which is Very simple. So let's see if it's working. No. Whoa. Interesting. I think I broke it. SQL Server logs. Database ID 8. Well, that's not good. Okay, I will have to recreate it. Which one is database ID? Eight is DS3 snapshot and 11 DS3. I see. We just have to change this because it's what loads the let's add a filter. Okay. Wait. Okay. Looks like it's working now. Let's have a look at the data it's collecting. So we have the tools database, which is a target for this auditing, and we have the last snapshot table. Let's have a look. And it doesn't contain anything at the moment. So let's wait for some objects to show up here. And oh, well, it's writing some information. But it's old information, this one, I think. Yes, it is. So let's have a look at this last snapshot. I excluded it, but we're not working on DS3. This one is working on the replay database. So we should be capturing information from that. Well, it's not working. And also, well, what I wanted to show you here is something I don't know if I will be able to show you now because it's not working on the database, the workload I wanted to run. But let's try to see. Anyway. Yep. It's waiting 30 seconds, but it's not. It's not doing what it's supposed to do. Well, I don't have the time to debug this in front of you, but I think you got the concept. So let's go on because this will be interesting for different observations. So if I had a working workload, I could show you that the performance impact of the streaming API has a cost, and that cost is differently split between the server, so where the events happen, and the client, so where the events are consumed. And it will depend on what the session captures, so that is the load you have on the server, and different events impose a different load on the server. So if you're capturing execution plans, these are very costly for the server to produce in your session. And the load you will impose on the client depends on what you do with the events. So once you capture them, you will do things. So in that script, we have seen that we have a data table in memory with objects, and we are constantly, for each of the objects that we capture, we are constantly looking up that data table by object ID, and that has a cost. So if I had a working workload, I could have shown you that CPU for the PowerShell script goes to the roof, because it has to look up the events in the data table, while the CPU for SQL Server is pretty low. Also, if the reader, so the client that reads all the events, gets too behind on the events that are created in the session, if it gets too behind, it gets disconnected. SQL Server decides to protect itself by disconnecting the API. So what you will have is an error in the reader that will be disconnected from the session. I tried to do that. I generated millions of events, and I couldn't get it to disconnect. This is documented. Documentation says that at some point, if the reader doesn't process the events fast enough, it gets disconnected. I had something like 100 million events in my queue, and it didn't get disconnected. So take it for granted, but I couldn't get that to work. If I had a working workload, I could show you here different solutions for lowering the client-side impact of the script. So I could try to fix it. Let's drop this first. Wait, I have an idea. I will try to revert to this snapshot if it's working, but I don't think so. Oh, maybe I have a backup. There was one? Oh, here it is. Okay. Let's try to... okay, so... Yep, I know. So let's drop it. Okay, by who? By me. Okay, so Okay, it gets tricky to troubleshoot in front of you while we're also recording it. Okay, so let's try to do something different. That would be a great idea, but I don't think it would attach to Hmm. Could work. I could try to take this offline. Take offline. Hey, it's offline. Whoa. Hmm. I don't think it. Hey. Cool. Oh well, I will just restore overwriting everything. Okay, so it's in DS3. No, it's in D. Restore DS3. Okay, okay. Doesn't look promising. Yep, but I could overwrite them. No? Why? It's all for this database, really. No, that doesn't look promising, really. And there's something wrong with this virtual machine. Sorry? No, it has 8 gigs. Oh, let's try again. I think there's something wrong with the disk. Oh well. I cannot show you the CPU impact, but we have different solutions to redo the same thing. So attaching to the extended event sessions without imposing a huge load on the client. So one possible solution could be instead of using a data table, you could use a hash table. So I'm a bit lost in this moment. So this is okay, this is one that I already showed you. And there's a faster solution that instead of using a data table, uses a hash table. So you could have nested hash tables, and this is what I have here. Oh, I don't remember where that piece of the code is. Okay, so you have nested collections. Where are the collections? Oh, here they are. So dictionaries nested one into each other. So you have different layers of dictionaries. And that is slightly faster and uses slightly less CPU. Well, main point is there's some load on the server and some load on the client, so keep that in mind. We cannot do that, we cannot do this. So some other gotchas, some things that we mentioned but didn't explore completely. So the events are placed in a queue. So when you process these events, you read in them from the queue. And that queue lives somewhere. We don't know where exactly because it's not documented. And sometimes, as we have seen with replay, that queue doesn't get flushed. So the events are stuck somewhere. And the only way to push out the events from that somewhere is having more events captured, placed in the queue. Those events push out the ones that are stuck in that queue. And there's no way, no official documented way to control that. And the dispatcher latency on the session has no effect on this. And my suggestion could be to add to your session some event that happens from time to time. So checkpoint or something like that. And it happens regularly and it flashes, it also flashes your queue. And okay, so other things you could do with the streaming API, you could capture some events and save them to a database table, as we have done with auditing thing. And so saving some information captured while monitoring an instance and saving it to a database file, it sounds familiar. It's what the data collector does. So in order to use the data collector with the extended events streaming API, what we need is a specialized collector type that we will use combining extended events with the data collector. How many of you use the data collector? One. Okay, that's one more than last time I asked. And the data collector is not very popular because it has its quirks and it's not a complete solution. And one of the things it misses is a UI, and it misses the ability to alert on some of the data that we are capturing. And with this project, the extended T-SQL collector project, we try to close that gap and add some information, some new abilities to the data collector. So it provides a graphical user interface to interact with the definition of the collector types, collection items, and everything that you are capturing. And it also incorporates two new collector types, the extended T-SQL collector type and extended XC reader collector type. The first one allows capturing LOB data. With the standard data collector, when you try to extend it by creating your own collection items, if you try to capture LOB data, it won't work because it uses an intermediate format when it writes to the cache before uploading to the target server. And that intermediate format is the SSIS raw file, which doesn't support LOB data, which is pretty unfortunate since most interesting data in SQL Server for DBAs is stored in XML, which is LOB. So what you can do here to overcome this limitation is using extended T-SQL collector type. It uses a different intermediate format, which doesn't rely on raw files, So you can capture XML and varchar max and that kind of things. Also, we have a collector type that can attach to extended events session, and using the API reads data from the sessions, reads the events from the sessions, and it can write that information to some target tables in the management data warehouse database. It also offers some alerting facilities. So when some interesting event is captured, you could fire an alert. It's free and open source. You can find it at Codeplex. I'm not one of the cool guys on what's the name of the thing? GitHub. Yeah, I don't even know the name, so I'm not cool. I'm on Codeplex. Okay, so here I will show you how the thing works. Okay, so when you install it for the first time, you have to do some initial setup. So you need to use this, which is the graphical user interface. You just have to tell to which instance to attach, and then you have the UI. You have the list of the collector types, and the first thing you will do once installed, you have to install the collector types to the target instance, and you do that with this button, and the outcome is that you will have these two collector types in your instance. They will be added to the ones that are built in. These ones are what you will find in a vanilla SQL Server installation. And then we have some collection sets. These are the system ones that you have in data collector, so disk usage and query statistics, server activity, utility information. This is the one used by the utility control point. How many of you know what utility control point is? One. That's one more than last time I asked. And then we have a special collection set here for monitoring blocking and deadlocking, and it captures blocked processes and deadlocks using the streaming API. Let's have a look at how it works. So we have this collection set, and this is some information that is available even on the built-in SSMS properties window, but here it's also updatable. You can only read it in the properties window in SSMS. And then let's have a look at the collection item example, the deadlocks connection item. What it does here, it has some parameters, and the parameters are a name of a session to attach to, so we will have a deadlocks extended events session, and the definition of the session. So we have to provide a script with the definition of the session. We have to decide the name of the output table. In this case, it's deadlocks, so it will be the name in the MDW database where the deadlocks will be saved, and the list of the columns we want to take from the extended events session to save in the target table. The creation of the table in the MDW database will be based on the columns that we have here and will be automatic. And then we have another tab, and this takes care of alerting. So we have to provide a database mail profile, a target for the notification, subject, importance, and the list of the columns to include in the email. In this case, XML report. Okay, so here to show you that it's working and it's not pretending to work. What we need is to generate some deadlocks. And because we don't have SharePoint, we will have to generate deadlocks in some other way. So we will use this script. And we also need an email application. So let's start an email client. We have an email server. Oh, demo expired. Perfect. Okay, so let's generate some deadlocks. Okay, we're getting some deadlocks now. And the deadlocks should arrive here, but since the client expired, they are not arriving. I think it expired tonight. Fantastic. And what we get here is an email that looks like this. So you get an email that contains all the block processes here. And you have the XML of the XML report of the deadlock. So it's not very convenient to look at here in the email. What you can do is you can create a reporting services instance with some reports that read information from your MDW database. So you have your MDW database here. Sysutility MDW. You have your custom snapshots deadlock table. It has some data in it. And what we want to do is extract the information from this column. So let's have a look. MDW reports. We have MDW overview custom report. And we have all the collection sets available here. We have one report for deadlocks and block processes. I will have a look at the deadlocks here. I just have a summary with a count. I can see all the deadlocks here, and this is the deadlock graph. If I click on the time, I can download the XML report. Please wait. Yeah. Okay, it refused to work. So many things have don't work today. Fantastic. And I can download it and open it in Management Studio. Well, fantastic, but you get the idea. Okay, another thing you could do, you could open event files using the same API. And shredding XML, we have seen, is ugly, is CPU intensive, is hard, it sucks. Nobody likes shredding XML. You like shredding XML? Nobody likes shredding XML. Okay, so let's have a look at how reading XML files with the API works. Okay, you could use LinkPad to open a file. LinkPad, how many of you know this tool, LinkPad? Okay, it's really easy to instantiate the same object, the queryable event data object. The only thing you have to do, you have to provide in this query properties window the path to the two DLLs that provide the information, and this is a location, you have it in your client tools. And you just have to open the file and then dump all the events in the file. So if we run this, we obtain this, and we can explore the data that we have in the file. And so, example here is a deadlock. We could look at the fields, and this is an XML report field, and we could have a look at the contents of the file. So really, it's really easy to do that. And another thing you could do, you could be extracting all the deadlocks from the file as saving each deadlock to its own file. So let's try to do that. We have a PowerShell script here, and what it does, it uses the API, again, same object that we used before. Again, it's this one, but this time the argument, it will only be the name of the file. So we're not attaching to a session live this time. And for each event in the file, if the name of the event is XML deadlock report, we extract the contents of the field XML report and we write it to a file in temp deadlocks. Okay, so let's try to do that. Whoop. And PowerShell and extract deadlock graphs, and here it is. And we have a different file for each deadlock that was in the file, in the events file. So it's really easy to use the API even for reading the data from a file. Okay, so summing up, the streaming API is a lesser known target type. We could think of it like this. It provides a convenient way to process events as soon as they occur. You will have to do some coding. You don't have to learn C# because you have also PowerShell in your hands. If you don't want to write code at all, you could use extended T-SQL collector that will do everything for you. You just have to provide some parameters to make it work when your databases are not corrupt. So thank you very much. And you have your resources here, some links for you. And if you have questions, the time is up, but I'll be out of the room to answer your questions.